In this video, we will deal with another passive element called inductor. What is inductance and what is the power equation of inductance and what is the energy stored by an inductor. In the last video, we discussed about resistor. So now let us deal with inductor part. So what is an inductor? It is an electromagnetic component. This you need to remember. If they ask you what is an inductor, you need to tell that it is an electromagnetic component that stores electrical energy in a magnetic field. That is called as an inductor. And see here, an inductor is an electromagnet and it is denoted by letter L. This denotes inductance, or it can also be called as an inductor. And the value of inductor is inductance. So this is the basic knowledge you need to have regarding what is an inductor. So if you understand that, we can deal with inductance part. So in brief, inductor means it is an electromagnetic component. What that electromagnetic component do? It stores electrical energy in a magnetic field. It stores the energy that is present in the magnetic field. So in short, they are telling you that it is an electromagnet. It is denoted by letter L and the value of inductor is inductance. So now let's see what is inductance. So what is inductance? It is the property of conductor. What is conductor? Which allows the passage of electricity is called a conductor. And this property of conductor which opposes any changes in magnitude. So what is meant by any change in magnitude? Suppose I am having my 10 amperes of current flowing through the given material and suddenly it changed to 20 ampere. So this particular change is called as change in magnitude. And what is meant by change in direction? Suppose my given 10 amperes of current is flowing in this particular direction and suddenly it changed to this direction. This is called as change in direction. So this property of conductor which opposes any changes in magnitude or direction of current passing through the material is called as inductance. What is unit of inductance? It is Henry, which is denoted by capital H. And what is the symbol? It is the coil symbol. Okay, and now let's see the formula. Formula is V is equal to L into di by dt. This di by dt is called as change in current. We'll discuss it in the later part, but for time being, V is equal to L into di by dt is the formula. Now let's see the power equation. We all know power is equal to V into I, which is nothing but product of voltage into current. Now we have V from the formula of inductance. We have V is equal to L into di by dt. This is the part of V, and in turn I have my I. I'm substituting V is equal to L into di by dt in power formula. So this is my V part. And now what I'll do, I'll multiply this thing. So I'll get Li into di by dt. So this will be my power equation with regarding to inductance. So now what I'll tell you is this di by dt which you are having, this particular thing is called as change in current. Since power you will measure it in watts, we'll include watt here. So the final equation of power with respective inductance will be P is equal to Li into di by dt watt. So this will be your power equation. Okay. And now let's see the energy stored in an inductor. What is the formula of energy stored in an inductor and how we can tell that this particular energy is stored in an inductor? So energy stored in an inductor is given by W is equal to half L I square. I'll tell you why this is half L I square. So in this case, W is nothing but the energy stored by inductor. L is nothing but your inductance, and I is nothing but the current. So now see why this particular formula will arise. So we have W is equal to half Li square. So here always the energy stored will be directly proportional to the square of current flowing through it and inductance of the inductor. So this is why we'll get this particular formula. So energy stored will be always directly proportional to the square of current flowing through it. Square of current means I square, and the inductance of the inductor. Inductance of the inductor is denoted by capital L. So finally energy stored in an inductor is nothing but W is equal to half Li square. So this is the concept of inductor. And now let's see the phasor diagram also. So this is the phasor diagram, but I don't know what this axis represents and this axis represents. This axis generally represents your current, and this axis generally represents your potential difference. Which is nothing but your V. So now we can say that by seeing this diagram, we can say that our theta will be 90 degrees. Okay. Now in the resistor part we dealt with lead and load, which I already told you that this lead and load concept will be coming in your inductor part. Now how can you tell that this particular point is lead and this particular point is load? In any given phasor diagram, the topmost value which you have, suppose I am having this as V, so my V will be the leading point. If I have here I, then I will be my leading point. ఇక్కడ ఏమవుతుందంటే ఇక్కడ నా టాప్ మోస్ట్ పాయింట్ V కాబట్టి I can tell that V is the leading point. So now I can in the form of a sentence I can tell that here voltage leads the current by 90 degrees. Why we are writing leads? ఎందుకంటే ఇక్కడ టాప్ మోస్ట్ పాయింట్లో V ఉంది, మనకి ఇక్కడేమో I ఉంది. సో V is leading 90 degrees by current. So this is the thing which we are representing in the form of a statement. So this is the phasor diagram of inductor. I hope you understood the concept. If you are having any doubts, let me know in the comment section so that I can make it clear for you all. And thank you for watching.